I will be speaking about vaccinology from basic principles to new development. I am Dr. Amit Bhattacharya, Associate Professor at Department of Zoology, Ramjas College, University of Delhi. So in this part of the lecture, we will be talking about what exactly vaccines are and how these vaccines are prepared, getting a clue from the pathogens, and what are the different types of vaccines which are available in the market and how the developmental process takes place. So before going into all these particular topics, let's discuss what exactly the vaccines are and the pathogens are. Now, the pathogens, as we know, are the microorganisms which are disease causing elements with us. Okay, they can be viruses, they can be bacteria, fungi, like this one. Now, the vaccines over a period of time, they have helped the human races to successfully defeat many of the life-threatening diseases such as the meningitis, tetanus, measles and the polio over there. Now, we now know that there are about 20 or more life-threatening diseases against which the vaccines have been created, and these vaccines have increased and helped the people of all ages to live longer and have a healthier life. Now, the immunization, which means that how the vaccines are given to the particular person age, are currently preventing about 3.5 to 5 million deaths every year from these diseases. Now, how does the vaccine works? Now, the vaccines generally work with the help of the phenomena that we know that the pathogen is a bacterium or virus or parasite or a fungus that can cause the disease within the body. Now, each of these pathogens are made up of several subparts which are unique to these particular pathogen. Now, these unique segments which are present on the surfaces are taken up to develop the vaccines over there. Now, whenever these pathogens get into the human body, they create or elicit the formation of antibodies, and these particular parts are called as the antigen of that particular pathogen. Now, the antibodies produced in response to these pathogens antigens are important part of our immune system, and we consider that these antibodies or the immunoglobulins are the part of the immune system or the immune defense mechanism which help us to neutralize these particular pathogens. So, when the human body is exposed to any of these pathogens or the antigens which are present on the surface of them, it takes some time to the immune system to respond and produces the antibodies against these particular specific antigens. Now, let's take this image to show how exactly the vaccines works. Now, if we see over here, some of the pathogens are shown which can be bacteria, fungi or the viruses. Now, each of these pathogens, if we see on the surface, have got certain molecules which are present, which are called as the antigen, and these are the molecules which elicit or they activate the production of the antibodies. So, whenever these pathogens get into our body, what happens is our immune system immediately recognizes them as the foreign particle and they start acting against these particular pathogens, producing certain antibodies, and if they remain for a longer period of time, there may be a development of the memory response or the B cell response which also takes place over there. Now, the vaccine development takes place in various phases. So, this image shows the preclinical phase to the approval phase over here. Now, if we see, the starting phase is called as the preclinical phase, where these particular compound or the vaccine candidates are checked in the laboratory conditions. So, initially they are developed in the laboratories, then they are checked into the mouse model systems or the animal model systems for their pathogenicity and the immunogenicity over there, and once we get the data, once we confirm the data from these animal model system, we move to the further systems which are the clinical trials. Now, before getting into the clinical trial, there are certain data which has to be submitted into the approved agencies for getting the approval for the clinical trials, where we require the voluntary or the patient volunteers or the patients over there for checking the vaccines candidates over there. Now, over here there are different phases, phase 1, phase 2, phase 3. So if we see the image, there is an increase in the number of the volunteers over there, or the number of the patients over there for checking that particular vaccine candidates. And once this is done, it gets a approval, and then after certain checks it comes to the market for the immunization processes. Now, before going into the vaccine, let's take up the brief history of the vaccination and how these vaccines were created over a period of time. Now, the concept of these vaccinations came up very early in the 15th century actually, where different parts of the world, the people over there attempted to prevent certain illness by intentionally exposing the healthy people to smallpox lobules over there. A practice which is many a times known as the virolation. So virolation is a name for the smallpox which has come up. So now these things happened over a period of time, and subsequently the vaccines got into the picture. In the year 1796, May 1796, English physician Edward Jenner, he for the first time inoculated a 8-year boy whose name was James Philip with certain cowpox sores which were taken up from the hands of the milkmaid. He found very interestingly that the people who were working on those particular, who were milkmaids, they were not getting the smallpox virus attacks over there, because they were attacked with certain similar kind of viruses which were called as the cowpox over there. Now this particular interesting fact he took up, so that 8-year boy was injected with these collected cowpox sores over there. Now subsequently, initially the boy was unwell for several days, but subsequently after few days the boy recovered fully, because the boy's immune system came up with certain antibodies which can fight with these particular cowpox or the smallpox viruses over there. Now 2 months later, in the July 1796, Jenner inoculated Phillips with the matter from a human smallpox source in order to test the Phillips resistance, whether that boy has developed an immune system against the smallpox or not. To his interest, he found that the boy remained perfectly healthy and there was no development of smallpox in that particular boy. So the term vaccine was later coined out, taking up the Latin word for cow, or the vacca. So the word or the term vaccine came into the picture. So this was one of the major breakthrough in the field of vaccination, and how the vaccines started developing up in the commercial market. Now subsequently in the 1796, as we just discussed, Edward Jenner, he developed these particular vaccines against the smallpox, inoculating in the 8-year boy. Now in the year 1885, Louis Pasteur, he successfully prevented rabies through a post-exposure vaccination. So similar kind of things was used. So what he did is he attempted to use the vaccine on humans twice before, and injecting a human with a disease agent, that is still new and uncertain method. So that's how he developed this particular method. Now in the year 1918 to 1919, the Spanish influenza pandemic came into the picture. Now this pandemic was lethal because there were about 20 to 50 million people worldwide who got killed because of this pandemic. So the various countries got interested in developing the vaccines for this particular pandemic. So we will be discussing about, when we will be discussing about the various types of vaccine, we will be discussing about these Spanish flu vaccines also. So the Spanish flu vaccines got also into the picture. Now the next one which comes up was in the year 1976, about the smallpox eradication program. So this program involved more than 30 countries, where through surveillance and vaccination, the smallpox was focused to be eradicated. Now in the year 1971, the measles vaccines, which was initially came up in 1963, was combined with the various other vaccines which were against mumps and rubella, and it was called as a single vaccination process, MMR vaccines, measles, mumps, rubella vaccine, and it was given up by Dr. Maurice Hilleman. So in the 1971, this major breakthrough also came into the picture. Now in the year 1988, the smallpox vaccination or the eradication picture came into larger context, and many of the countries came into the picture to fight against this endemic. Now India also played a very major role in eradicating the smallpox and these particular disease conditions from their countries. Now this is a picture which is showing the polio eradication in India. So we can see over here how the different medical volunteers, they are helping to give the drops of the polio at the various locations, and how over a period of time we could defeat this polio from the India. So India polio eradication program in India played a very important role in ending the polio now. Now, in the year 2016, the success of the meningitis vaccine project got highlighted, which was one of the public-private partnership which came into the picture, and this vaccine also got developed. Now, in the year 2019, the WHO recommended the vaccines, or they developed the vaccines for the Ebola viruses also, which became a very major breakthrough in the vaccine development process. Now, in the year 2021, the WHO, as we know, declared the pandemic, which was the COVID-19, and how the different vaccines against the COVID-19 were developed over a period of time. We will discuss when we go into the types of the various vaccines. Now, in the year 30th January 2020, we know that the director WHO, he declared the outbreak of the novel coronavirus 19, which was SARS-CoV-2, as a public health emergency of international concern, and on the 11th of March, WHO confirmed that the COVID-19 is a pandemic. About a year after this one, the first case of the COVID-19 as they detected, the first COVID-19 vaccine doses were also administered. So there were different types of COVID-19 vaccines which were developed over a period of time, which we will see how the different vaccines came into the picture. Now, before going into the vaccines, development of the vaccines and the various types of the vaccines, we should understand about our immune system. Now, as we know, in our immune system, whenever a foreign particles come or invade into our immune system, which can be the bacteria, viruses, parasites or fungi, what happens is our immune system immediately recognizes them, and they start developing the various immune cells like the T helper cell, T cytotoxic cell, or the B cell. So B cells are the one which releases the antibody which neutralizes and fight with these foreign particles. Now this is a diagram which is showing how exactly when a pathogen enters into our body, how exactly it is being processed and how it is shown onto the surface of the antigen processing cells, and how they are recognized by the immune system. Now the immune system works in whenever there is a foreign pathogen which comes into the picture, these phagocytes or the macrophages, they come in a close proximity. What they do is they engulf these particular pathogens into their phagosomes, and these fuses with the lysosomes which are present in these particular macrophages, and these lysosomes, as they have got a acidic conditions, they neutralizes these particular pathogens, and subsequently they are released over there by neutralizing them. So this is how the immune system works in a normal process. So we can see over here there is an image which is showing how a macrophage is engulfing the foreign particle or pathogens over here. Now this is an image which shows the concentration and the isotype of the various serum antibodies which are formed from the primary and the secondary immunization with the antigen. So primary means when the first dose of the immunization is done, that is the primary dose, which is a small peak which comes into the picture, and secondary is the one because there is a development of the memory cells which happens in the secondary during the secondary immunization. So whenever we get a infection from that particular pathogen, there is a high level titer of the antibodies which is produced, and it immediately neutralizes all the pathogens which has invaded our body. Now there are two different concepts of the immunization also, which is one is called as the active immunization, the other one is called as the passive immunization. So the passive immunization is the one where we acquire the immune system from the natural processes. Okay, like there is a transfer of antibody which takes from the mother to the fetus condition, and in the artificial immunization where a vaccine is given to a particular patient, such as the injection of the antibodies or the vaccines for developing the antibodies in that particular thing. So if we see the passive immunization, which includes the natural maternal antibody which flows from the mother to the fetus over there, while the active immunity is the one which generally develops with the help of the vaccines. So there are different forms of the vaccine which we will be discussing over a period of time. Now, these passive immunization, they generally involves the transfer of the maternal antibodies across the placenta to the developing fetus. So the maternal antibodies are for the various type of diseases such as diphtheria, tetanus, streptococci, rubella, mumps, polio vaccine. So this gives a protection to the fetus. So the maternal antibodies are also present in the colostrum and the milk, which provides a passive immunity to the infant also. Now, the passive immunization is a major type of immunization which comes at the basic level. Now, how exactly the vaccines work? So, vaccines are basically, they are the weakened or the inactive part of a particular organism which we call it as a pathogen that triggers a immune response within the body. So, if we see over here, this is a pathogen which is there. So, if we see on the pathogen, there are certain blocks which are present which can elicit the immune system over there, which are called as the antigen. So, these particular antigens are taken in, and whenever they are injected in the body, these antigens are recognized by the body as the foreign particles, and immediately the antibodies are synthesized in the body which attacks and neutralize whenever there is such kind of infection which occurs in the body. Now, let us come into the understanding of the various vaccine technologies. Now, the vaccines technology have grown over a period of time, and there are different kinds of vaccines which have got developed, like the live attenuated vaccines, chimeric live attenuated, inactivated vaccines, subunit vaccine, and nucleic acid based vaccines over there. So, we will come into some of these vaccines over here and discuss some of the vaccines over here. Now, the first one is called as the whole inactivated vaccine or the live attenuated vaccines. Now, as the name is suggesting, inactivated vaccines, it means that the pathogen has been inactivated with the help of the heat or certain chemicals, which means that they are no longer capable of replicating or causing disease whenever they are injected into the host. But whenever they are injected, they can elicit or they can trigger the immune systems against that particular pathogen, producing certain antibodies which remain over a period of time. So, whenever we get an infection, these pathogens are immediately neutralized by the already present antibody which have got elicited from these whole inactivated vaccine. The second one comes the live attenuated vaccines. As the name is suggesting, attenuation means they are not inactivated, but they have become inactivated by growing them in a abnormal conditions over a period of time. So, attenuation are often achieved by growing a pathogenic bacteria or the virus for a prolonged period of time under abnormal condition. Now, if we see this table over here, this table shows how the two vaccines are differently engaged. One is inactivated, the other one is attenuated vaccine. Now, let us come into some of the live attenuated or the avirulent vaccines, which means that they cannot cause the disease in that particular person where it is injected, but they can elicit or they can activate the production of the antibodies or the memory cells. So, these particular vaccines, they have got a capacity for a transient growth or the replication within the injected host, and for a prolonged period of time they can activate the immune system in that particular individual, because the epitopes on the surface of the attenuated organisms are present. So, they elicit a immunogenicity response in that particular organism, producing the memory cells which remains in a body for a longer period of time. Now, The live attenuated or the avirulent vaccines, which are whole organism vaccines, they require a single immunization dose over there. They can induce both cell mediated and humoral response. One of the examples of the avirulent vaccines are the Sabin polio vaccine or the BCG vaccine, Bacillus Guelmette-Guerin vaccine. And now one of the major disadvantage of the attenuated vaccine is there is a possibility that they may revert back to the virulent form. So there is one major disadvantage with these particular attenuated vaccines which is there. Now the whole organism vaccines, there are different whole organism vaccines which are there. So we can see over here some of the vaccines are shown, like the tuberculosis live attenuated vaccine, which is the BCG vaccine, typhoid, which is a live attenuated vaccine, then the measles, mumps, polios. So all these are the live attenuated vaccine. So we'll come into some of the live attenuated vaccine. One of the first example we come over here is for the tuberculosis. Now this BCG vaccines was developed with the help of the bacillus of the Guelmette-Guerin strain of the Mycobacterium bovis. Now the Mycobacterium bovis is the one which causes the disease which is called as the tuberculosis. Now the BCG was developed by growing this Mycobacterium bovis on a medium containing increasing concentration of the bile. So what happens is, when this particular strain pathogen was grown over a period of time on the abnormal conditions, what happens is it lost its property of disease causing, but it remained over there. Whenever it was injected into the body, there were activation of the immune system in that particular thing. The next one comes the typhoid vaccine. So Salmonella typhi is the agent which causes the typhoid fever. So this is a acute febrile enteric disease which is there. So again, this is a live attenuated vaccine which was developed. So this is a orally administered vaccine. So what happens is, whenever this vaccine doses are given to the person develops an immune system which remains for a longer period of time. Now the next example is the development of the polio vaccines over there. Now the Sabin vaccine is discussed over here. This vaccine was developed by the scientist Dr. Albert Bruce Sabin. Now between the year 1961 to 1963, so he was convinced that the polio viruses primarily lived in the intestine. So what he did is, he focused on isolating the mutant form of these polio viruses which were capable of producing the disease condition. Now then what he did is, he grew them in abnormal conditions, so that these particular lethal forms, they lost their virulency, and subsequently the vaccines got developed. Now these vaccines got developed and they provided a protective immunity against all the three strains of the virulent polio virus. So in this part of the lecture, I discussed about what exactly the vaccines are, how exactly the vaccines start working in, and we discussed few of the examples of the live attenuated vaccines, which include the BCG vaccine, typhoid vaccine and the polio vaccine. Rest of the vaccines we will be discussing in the next part of the lecture. Thank you very much.